Hi everyone, this is Giacomo here from Linux Foundation. Today I will show you our new decentralized application for making digital handshakes. A digital handshake is an implicit agreement where the concept of trust relies on a face-to-face meeting. Nowadays, more and more of these interactions are made through centralized online platforms, shifting the trust from parties to the platform itself. This leads to a series of problems, from the lack of trust among stakeholders to missing transparency in data and process, including late payments and costly mechanisms for dispute resolution. Our solution aims to migrate the concept of trust from the platform to the code. We built a blockchain-based solution on top of the EOS.io protocol due to its technical and economic efficiency. The transparency on identity, data, code, and payments allows users to agree based on a request proposed model. The on-chain business logic is realized through three different smart contracts. The token manages a native digital handshake or DHS ERC20 token. The service guarantees core handshaking operations. The escrow implements an ad hoc service for secure and event-based token redistribution. The role of the blockchain is critical for answering the problems mentioned above. Now let's start to explore the features of our solution, beginning with the trustable negotiation process. Suppose that Alice is the director of an online magazine that needs to hire a freelance to write a blog post. Alice knows Bob, a freelance writer, and they want to make an online digital handshake using the platform. Alice logs into the application entering her credentials. After a quick look at her user bar, she navigates through the request page for posting a new request. Alice fills in the form and posts the request by sending a transaction to the blockchain. After the transaction inclusion in a block, she can see the updated information and verify that it has been recorded correctly. Also, because the contractual terms could be long and complex, they are stored off-chain. The application enables to check the integrity through a match between the on- and off-chain data hash. Now we are logged in as Bob. The Explore page shows the requests made by other users, including Alice's one. Bob can see that Oscar, another user, has offered himself as a possible bidder for Alice's request. However, because the request is still open, Bob can propose himself too by sending a transaction to the blockchain. Alice can now see both proposals from Oscar and Bob. She wants to continue with Bob, so she clicks on his name and notarizes these on the blockchain. The Handshakes page shows all handshakes where the user has participated. A draft for a new handshake between Alice and Bob is now created. As you can notice, Bob is negotiating the handshake. To record these changes, Bob sends a transaction to the blockchain. Alice receives the notification of these changes, verifies the correctness, and decides to confirm this agreement. She notifies Bob of her choice by sending a transaction. Received Alice's confirmation, Bob countersigns the agreement on-chain, putting an end to the negotiation step. The blockchain negotiation process allows Alice and Bob to have confidence in the integrity and immutability of the handshake agreement. Now we are going to see how it can be possible to guarantee security on payments. The escrow smart contract requires a certain amount of tokens to guarantee payment for the handshake service and in case of a dispute. Alice has to lock 280 DHS tokens where 250 tokens are for the Handshake payment and 30 tokens are staked in case of a dispute. As you can notice, 280 tokens have been moved from current to locked balance. Contrarily, Bob, which does not have to pay for any other service outside of a possible dispute, has to lock only the 30 DHS tokens. Now the Handshake is in execution and Bob has to provide the article on time. Suppose that Bob finishes behind the deadline. The smart contract has a time-based constraint that does not allow Bob to notarize the termination. In this case, the solution ensures that the two parties can explicitly proceed with the recovery of the blocked amounts of tokens. Respectively, 280 DHS tokens for Alice and 30 DHS tokens for Bob. Now both will be able to use their respective tokens again to make different handshakes. In the other case, Bob finishes on time, and he can proceed with the on-chain authorization of the article termination. After Bob's article evaluation, Alice has two possible options: confirming and proceeding with the handshake conclusion, or starting a dispute process. The first option allows Alice to send a transaction that notarizes the acceptance of the service provided by Bob. This triggers the unlock of the tokens, firing the automatic payment process. Alice gets back the 30 DHS tokens because the dispute has not happened, and an increment in rating. At the same time, Bob gets back the 30 DHS tokens and he earns 250 DHS tokens from Alice as payment for the article. Bob's rating is also increased by 1. The handshake is now complete. Payments have been made and everything is transparent and visible by anyone. Now let's see what would have happened if Alice had found Bob's article not under her expectations and wants to open a dispute process. Alice opens the dispute process by sending a transaction to the blockchain. Then the application requires the motivation for the dispute opening. This data will be stored off-chain for the same reasons as mentioned for the contractual terms. Bob will do the same, motivating his position and defending his work. Once the motivations have been obtained, the voting process can officially start. Now we are logged in as Mark, one of the 3 jurors selected in a pseudo-random way by the smart contract. Mark verifies the dispute motivations provided by Alice and Bob. After some time, he decides to vote in favor of Alice, the dealer. Alice also receives a vote from Sarah. The last juror, Rick, decides to vote for Bob. Once the vote of the last juror has been received, the dispute process ends, decreeing the winner, in this case, Alice, the dealer. At this point, the escrow smart contract unlocks the tokens. Alice, the winner, got back the 30 DHS tokens plus the 250 DHS tokens because she did not have to pay Bob. Also, she got a rating increment. Bob did not receive any payment, but he got a rating decrease. Also, he has lost his 30 DHS tokens for dispute resolution. The on-chain dispute resolution mechanism has equally redistributed these tokens among the 3 jurors, which receive 10 DHS tokens each. To find more about our business model strategy for tackling the main challenges when building secure digital handshakes, please have a look at our Medium article linked in the description down below. You can have a look at the decentralized application source code and more technical aspects regarding our implementation by visiting our GitHub front-end and back-end repositories.